Okay, we're going to look at equations in standard form, and also we're going to look at converting between different forms of equations, and that often happens with equations in standard form. So get your name, date, title, and let's see what is standard form. What's it all about? Well, for linear functions, standard form is ax plus by equals c, where a, b, and c are just different numbers, and they're supposed to be whole numbers. So notice that x and y are on the same side. This is the first form where we've had this. And a lot of people think this kind of looks the neatest. It looks nice to have just, it looks like a simple addition problem. And it looks even better because the coefficients should be whole numbers, and so that's what we want it to look like. And the last thing we need to know is that the coefficient of x, again, coefficients of these numbers that go before variables, the coefficient of x should be positive because we want to start off with something positive. And let's say you didn't have a positive coefficient with x. Well, we know from equation rules that you could just flip it to the other side. We could flip the sides of all these using some addition and subtraction, and the sign would change. So they look really nice. We have this positive number of x's, and we add some b's, or we subtract some b's, and we get a number c, and they're all whole numbers, so it looks nice. And why is it useful? Well, it's useful for graphing quickly with intercepts. So it's really easy to calculate intercepts if you're given standard form, and if you can find the x-intercept and the y-intercept, well, you have 2 points, and that determines your line. And then the last thing we need to know is that we should be able to convert other equations into standard form or from standard form using our basic equation rules. So it's really nice and easy to use equation rules when you're looking at an equation in standard form. Now this is just words so far, so let's make it real. Let's get to work on some problems. And here's the first one. It says graph the following equation. And yes, that is standard form. We have positive coefficient to start. We have whole number coefficients for the y that's on the same side, and then we have a whole number on the opposite side. So let's see, what are we going to do to graph the following equation? Well, I can find 2 points very quickly by doing this, by saying, what is the x-intercept? And what does that mean? What is the x-intercept? Where does the line cross this x-axis? Well, what do we know about the points on the x-axis? Well, they haven't risen or gone below, so their y value has to be 0. And why is this useful? Why is it useful? Because we get to plug in 0 for y. So if you plug in 0 for y, you just have 3x minus 20 times 0. We're not even going to subtract anything. That just cancels out that term. So we have 3x is equal to 18. So again, this is when y is 0. If y is equal to 0, then we'll plug it in, and we'll get 3x is equal to 18. We can divide both sides by 3 to undo that operation. And what do we get? We get x is equal to 6. So we know that this is a point 6, 0. When x is 6, y is 0, or when y is 0, x is 6. Okay, well, what about the y-intercept? That's the value of y when x is 0. So if we don't move to the right or the left, we're going to cross the y-axis. So if we plug in 0 for x, we have x equals 0. And what do we get here? We would get 3 times 0 is 0, so we'd have 0 minus 20, or we just have negative 20 is equal to 18. Negative 20y, that is. Alright, we need to solve for y. So our x was 0, what's our y going to be? Well, we'll divide both sides by negative 20 to cancel that out. We just have the y because a negative divided by a negative just leaves us with positive 1y is going to be equal to negative 18 over 20. We can simplify that. It's a fraction already, but if we divide by 2, it's just negative 9/10. And that's really nice. So if x is 0, what do we get out for y? We got negative 9/10. And hopefully this just drives home the fact that whenever we're finding points or plotting points, we're just finding x and y pairs that work together to make this equation true. If you plug in one for x or y, you get out the other for the other variable. So let's plot this really quickly. Well, what do I need my x scale to be? Well, I know it goes from 0 to 6, so that's pretty basic. Let's leave our x scale at 1. So just going to go up by 1 each hash mark. What does our y do? It goes from 0 to negative 9/10. What I'm going to do here is I'm going to make this one negative 1/10. I could do it as a fraction, but I'll do it as a decimal, negative 0.1. So 6, 0, where is that? It goes, we run, then we rise, so 1, 2, 3, 4, 5, 6. That's the 0.60, and and I'll name it just for clarity's sake. And then 0, negative 9/10. So 0, I didn't move at all right or left. We ran 0. Then we'll rise negative 2/10, 3, 4, 5, 6, 7, 8, 9. So this would be 0, negative 9/10. So it would be 0, negative 9/10. And you got to be good with that conversion between fractions and decimals at this point. And we'll just connect these two lines. I wish I had a straight edge. You should be using a straight edge, because those should intersect through the center of the point. They didn't, but I'm going to act like they did. We'll draw a thicker line, that way I get it. So we already graphed our line, and it was really quite easy just to plug in 0 for x and y and found out what we got for the other variable. So we just found the intercepts, and we were able to graph pretty quickly. So that's useful, and that's great. Let's look at another problem. This is something else that we need to be able to do. It says, change the following equation into standard form. Well, what form is this? Well, this is point-slope form. We have the slope in front of this parenthetical, and we have a point negative 3/16 that's given to us. But if we're going to change it to standard form, what do we know needs to be true? Or what's going to be the process? Well, the first thing that I probably want to do is get rid of this parenthetical, because it's really kind of handcuffing me. It's not letting me do what I want. So I'll distribute that, and we now have y minus 16 stays the same on the left. Negative 0.5, negative 0.5, or negative 1/2 got multiplied times x, so it's negative 0.5x. And then negative 0.5, or negative 1/2, times 3 would be negative 1.5. And now what do we need here? Okay, well, I know that we need, for standard form, we need x and y on the same side. Do I want to get them on the right or on the left? The other thing I know I need is a positive x value, and right now we have a negative x value. So we better get rid of it on this side. Let's add 0.5x to both sides. On the right hand side, that cancels out. We're just left to negative 1.5, and that's okay for now. We got positive 0.5x. We have positive y. We have negative 16. Well, I know that we want all of our constants, all these numbers that stand alone. We know we want all of them to be on the opposite side. In this case, it's the right side. And we have 0.5, or 1/2 x plus y. We have to think about this one. If you're at negative 1.5 and you add 16, what do you get? Well, we can say algebra tiles. If you had 16 positives, you have more positives than negatives, but the signs are different. They'll cancel out, so we'll subtract. 16 minus 1 would be 15. 16 minus 1.5 has to go lower. That'd be 14.5. Now, the last thing hopefully you're seeing is that this is not standard form yet. And the reason is because we don't have whole number coefficients. But we can get them pretty easily. If you have 1/2 x, what can we do to both sides so that we no longer have that fractional or that decimal value? We can just multiply both sides by 2. And we're allowed to do that as long as we do it to both sides. So I'll multiply this side all by 2. We'll double everything on the left. If we do that, we got to double everything on the right. And what are we going to get? 2 times 1/2 is just x. So we just have 1x. We also have to multiply the y by 2. X plus 2y equals 14.5. If you double 14, you get 28. If you double 1/2, you get 1. So 28 plus 1 is 29. So here would be standard form for this one. X plus 2y equals 29. We have whole number coefficients. In this case, it'd actually be 1x. We have these variables on the same side, and x is positive. So we're looking good. So let's do one more practice problem before I set you loose. For this one, it says change to slope-intercept form, then graph. So what do we know about slope-intercept form? It's y equals mx plus b. Right now I have standard form, but I need to get that y alone. So I'll subtract 6x from both sides. I cannot combine these. These don't go together because they're not like terms. 11 is just a number. Negative 6x is a number of x's. So negative 2y equals, and I know that it's mx plus b, so we'll put the x term first, and that was a positive 11. Now what I want you to realize is that this negative sign fell down. That goes with the 2y. That's something people often forget. But to get the y alone, we also need to get rid of that negative sign and the 2. We'll divide both sides by negative 2. We divide it over here, we get just the y. That's what we want. Now since I'm dividing this whole side by 2, I have to divide each individual part by 2. So negative 6 divided by negative 2 would be 3x. And 11 divided by negative 2, well, that's a positive divided by negative is a negative. And 11 divided by 2 is almost like 10 divided by 2, but we need to get that extra 1. So it's negative 5.5 or 5.5. So now we've got slope-intercept form, and slope-intercept form is also easy to graph. We're just going to make a normal scale of 1 and 1. What's the easiest point to graph? What's the easiest point to graph? Our b value, y equals mx plus b, and b is the y-intercept, so we just have to go down negative 5.5. 1, 2, 3, 4, 5.5 is halfway to 6. And then I know that our value of our slope is 3, it's mx, so the 3 is the m value in front of the x. If it goes up 3, that's the change in y over the change in x, it means it goes up 3 every time you go once to the right. So I'll go once to the right, and I'll go 1, 2, 3, so we go to negative 2.5. So I have 2 points now. Does that look like a slope of 3? It does, because we're going up quite sharply as we go to the right. What are these points? This is 0, negative 5.5. And what's this one? It's 1. We went 1 to the right, and we went up 3, so that'd be negative 2.5. And that's exactly where we are. So there we go. We've practiced converting different forms. We've practiced using our equation rules. We've also practiced graphing intercepts. And these are all things that standard form is great for. So I'm going to leave you with 2 problems on your own. I'll erase this stuff so you can see it. The first one says change to standard form, and it's y equals 4x minus 13. So you need to put that in standard form. You need to know what standard form looks like and how to get there using equation laws. And then the next one, I just want you to graph the line for this equation and think about what is easy to graph when you're given an equation like this in standard form. So best of luck. Do that algebraic manipulation of the equation and also that graphing, and I'll catch you soon.